Okay, so looking at the second part of graphing quadratics. So a few more things that we can find when we go ahead and graph them. All right. So one thing that I would like to do is actually, hold on one second.
Hi, YouTube. Follow me on Instagram.
What's that for Instagram? What do you need, Dave?
Today we're learning about graphing quadratics part 2.
Yes.
Our wonderful teacher, Mrs. Sabia.
Oh.
It's a good day to meet. What is that?
Wait till you see.
Not like
Glue.
No. We should go for a walk.
Okay.
Oh, it's a stamp. That's so cool.
Next time you say that, I'm definitely.
I know.
What?
Okay, but we don't have that.
You don't need it. But if you behave, I might let you borrow it to make a stamp on your paper. So,
That made my week.
here's what I need to show you. Let's say, everybody, is everybody listening and paying attention? Okay, good. So let's say I had a vertex here, and then my graph went like this, and I went up 1, 2, 3, or 1, and da. Okay, so let's say I had some quadratic, I graphed it, and it looked roughly like this. Okay, so we've already talked about how to find the vertex, how to plot these other points. We are going to be looking at these specific things. If I already have this graph graphed, it's pretty easy to find the y-intercept, right? I would just look at the y-axis and see where my graph crosses the y-axis. So in this case, it'd be at 1, 2, 3. So my y-intercept would be at 0, 3. How do you suppose I find that, though, if I don't have a picture of the graph? What if I just have an equation?
You gotta do it without.
How? How would you do it without? You could go through all the effort of graphing it, but even if you do that, if you look at something like number, right here, number 9 on our worksheet, I don't see where it crosses the y-axis. Does it ever cross the y-axis?
Yeah.
It does. It's just going to be way off my graph. So even graphing it may not necessarily tell me that answer. So how would I find it? Yes! Yes! Think about it. Wherever your parabola crosses the y-axis, isn't x always going to be 0? Right? X is 0 right there. If I look at another one, like this one right here. This one, it just so happened to be at 0, 1, but x was 0. If I look at this one, x is 0 when it crosses the y-axis. So if I want to find the y-intercept without graphing, I just plug in 0 for x and see what I get out for y. It's just that easy. Okay? So to find the y-intercept, just plug 0 in for x.
So wouldn't you do the same for y, like, or to find the x?
Yes, basically, and see what comes out. I'll get there in a minute, though. So let me ask you this question. Will every parabola cross the y-axis at some point?
Yes.
Yeah.
No.
Yes.
No, wait.
It has to.
It has to.
No.
Wait, no. What if it's, so say it's, alright, say the vertex is above the y-axis.
Above the y-axis?
How does it even get above it?
Okay, so even if I had it above, so let's say I had another example. And let's say it was like way up here. and it went like this. Is this thing ever going to cross the y-axis?
Yeah.
Yes. This, guys, these arrows, right, indicate that it goes on forever. This is going to go up and to the left ever so slightly forever. So eventually, it's going to hit the y-axis. It's probably going to be at a really big number, but it's going to happen. So, guys, are you all with me?
Yes.
Those of you that said that it will cross the y-axis, you are correct. Every single parabola is going to cross the y-axis. How many times?
Once.
Once.
Why does it matter?
It's once. Because it's only going left. Because the one on the bicycle.
Exactly. It will only ever cross once. So take a look at this example, right? It crossed right here. This is going to continue on to the left. Guys, please. This continues on to the left forever. This side will continue on to the right forever. So it's never going to come back and cross that again. Same for every parabola. Every parabola that you look at is only going to hit that one time, whether it's on your graph or whether you can see it or not. So, yes, there will only ever be one y-intercept, and every parabola has one, okay? So, if you just want to note that down, every parabola crosses the y-axis exactly once.
Yeah, only would be a better word.
I have a
Okay, and that's exactly how I find it. So if I just take some random quadratic, say I had, oh, I don't know, y equals 2x squared minus 3x plus 5. If I want to find the y-intercept for this, literally all I do is plug in 0 for x and see what comes out for y. So the y-intercept would be, I plugged in 0 for x, and what would come out? 5. So this particular graph is crossing the y-axis at 0, 5. Okay, and that's a nice, easy point to have in addition to my vertex. Okay, so now Jordan said, wouldn't you do the same thing for the x-intercepts, just plug in 0 for y? He's absolutely right. Remember, we have 3 different scenarios that can come out. Do you believe that I got these stamps on clearance for $1?
Where?
God.
It was at Staples. I bought them all.
They're at Staples?
They were, not anymore.
This
You
year
got
you
more
can
than
try
one?
to use it.
Yes, because I know I'll use them for years, and as one dries up, I'll have another one.
Miss Sylvia, can I use one?
I think I got 5.
Jeez.
You gotta
They
take all
all
your
drive
notes
an hour
first.
drive.
Well, yeah, okay, you
I
can.
want to use one.
But we need one for taking notes.
Can I use one?
You're gonna pass it around, so be quick with it.
Don't break
Can
it.
you
Yes.
Don't worry.
It's going to be so
So, ladies, gentlemen, we've already talked about the 3 scenarios with x-intercepts, right? So you can have a parabola that crosses the x-axis twice, right? So once there, once there. You could have, what's another scenario? It doesn't touch the x-axis at all, so maybe it's just up too high or down too low, right? Because it could also be flipped over the other way. So I can have 2 x-intercepts. I can have no x-intercepts. Or the third possibility would be, yes, if the vertex happens to be on the x-axis somewhere. Something like that, maybe. That would be, that's a terrible parabola, but you get the idea. That would be 1 x-intercept. You already know how to find these, right? How do you find the x-intercepts of a parabola?
You do the thing.
Yes, literally that was the whole last chapter, was solving the quadratic, right? When you solve a quadratic, aren't you finding where it crosses the x-axis? Yes, so that's all you would have to do. So to find the x Y-intercept, or intercepts, right? Because you could get 2. Most of the time you're going to get 2, but it can happen that you get none or just 1. Plug in 0 for y and solve the quadratic. You have 4 different ways to solve quadratics. Sorry. You can do square rooting. You can factor. You can complete the square. Or you can do the quadratic formula. Okay? So you already know how to do this. That was the entire last chapter. If you're still struggling with that last chapter, I'm after school today. Or you can watch some of our videos on it. They're all there, okay? So, there's finding the X-intercepts. Now, is everybody okay so far? Now let's talk domain and range. Let's see. I think I actually want to kind of go back up to this example that we had here and zoom in on it a little bit. Did you need that? Did it?
Yeah.
Sorry. Thanks. Let me know when you're all set. Okay. All right. So I'm just going to. Isabella, are you all set? Okay. So let's just look at this example one that we have drawn out already. Okay? Is everybody listening? You with me? All right. So domain and range. You've heard these thrown around math classrooms for a long time now. Do you have any idea what they are? Right. Domain represents all the X values. Basically, it's like what numbers are you allowed to plug in that'll actually get you an answer back out. So, for example, if I take a look at this quadratic right here, can I plug in any value I want for X and get an answer back out? It may not be a nice number, right? But I could plug in 10. I can plug in 0.25. I can plug in negative 4,000. I can plug in any number I want, and something's going to come out. Do you agree? Now, if I had something, don't write this down in your notes, just as an aside. Say I was trying to do something like this. If I want to take the square root of x plus 3, if I plug in negative 10 for x, isn't that going to give me a negative under the square root? And I can't do that. So this particular example, I'm not allowed to plug in any number I want because it's not going to give me a real answer back out. So I'm limited here. Now, we're kind of lucky because everything that we're dealing with right now is a quadratic. And I can plug in anything I want into a quadratic and something will come out as an answer. So, your answer for the domain of basically every quadratic is that x is equal to all reals. Meaning, you can plug in any number that you want. Any number. Doesn't matter. You're going to get an answer back out. If you look at the graph, right? Won't this graph eventually extend to cover every single x value ever? Right? If you just kept this graph going, eventually it goes over every single number. Does that make sense so far? Range is a little bit different. Range is, okay, you're going to take the domain, plug it into your function. What's going to come out? What kind of numbers are going to come out for this? So, if this is my quadratic, right? Am I ever going to, no matter what I plug in for x, am I ever going to get a y value of -3? No, it's never going to happen. This is the lowest I ever get. And then every other y value that comes out is going to be bigger than that number. Do you see that? Does everybody see that? Right? So the range is just what y values are coming out when you plug in your domain. Well, all my y values, in this case, here's -1, -2, -3, right? Every single y value is going to be greater than or equal to -1. Do you see that? Is everybody with me? Because I have a feeling in 5 minutes when I'm asking you to find range, you're going to be like, how do I find that one? Because I don't think you're quite paying attention to me. So, range, all the y values that are actually going to come out. This quadratic will never get a y value of -2 or -3. It will only get y values of -1 or bigger. So what would I write for my range? I write y is greater than or equal to -1. So it's actually pretty easy to determine the range when you have a graph in front of you. So if I look back at this one here, number 4, from this worksheet, okay? What's the domain for this? What can I plug in for x? All real. I can plug in whatever I want, right? And to that equation right there, you can plug in anything you want to, and something's going to come out. Some real number will come out of this. My range, however, look what's coming out. Say it again. Yes, in this case, it's going to be less than or equal to 3. I'm never going to get a y value of 4, 5, 6, or any of these up here. It's only going to be from +3 down. So the range on this one would be y is going to be less than or equal to 3. It's what? That's it for the range. That's it. The y is going to be less than or equal to 3. Now, I mentioned a minute ago, yeah, that's pretty easy to do when you have the graph right in front of you. You're not always going to have the graph right in front of you. And it would be such a pain in the neck to make the graph just to figure out what the range is. There's got to be a better way if you don't have access to the graph. Turns out there is. See how y was less than or equal to 3? What did 3 have to do with this problem? It's the y coordinate of the vertex. Right. Now again, if I don't have a picture of graph though, how do I know if it's going to be y is greater than or less than? Yeah, you just go, well, is this a, how is my parabola? Is it up or is it down? So, let's kind of spell that out. Let me get another sheet of paper. So, to find range without a graph. You do need the vertex, okay? So find your vertex if you don't already have it. And actually, I'm going to say, and determine if it's a max or min. So remember we mentioned yesterday maximums and minimums with vertices? So, let me zoom out a bit. If you have an up like a cup graph, your vertex is a minimum because it's the lowest point on the whole graph. And this way, you would have a max, right? Okay, so let's just do an example problem. Let's say this is our quadratic. Let's say it's negative x squared plus 4x, I don't know, plus 2, right? So, I need to start off by finding the vertex. So negative b over 2a. So it'd be negative 4 over negative 2, so a positive 2. And then I'd have to plug that back in. Be careful, right? So I'd be doing 2 squared, which is 4, and then take the opposite. Negative 4 plus 8 plus 2. 6. Right? Isn't that right? Negative 4 plus 8 plus 2. Yep. And now tell me if this is a max or a min. It would be a max, right? Because my graph is going to be down like a frown. So it's going to be a max. Okay, so now once you have your vertex and you figured out if it's a max or a min, here's where you're going to go with that. Okay? So the range, will be y is greater than or equal to if, greater than or, well, hold on. Range will be greater than or equal to the y coordinate of vertex if you have a min. If vertex is min. Oh, sorry. And then it's going to be the other way, less than or equal to y coordinate if vertex is a max. So even without actually physically graphing it, I know that because in this scenario, I have a vertex at 2, 6, that's a max. That means my y is going to be less than or equal to 6 and not greater than or equal to. So the range would be y is less than or equal to 6. And I've got it. So now it's just a matter of kind of putting all this stuff together. Shall we try an example together?
Nope.
All right. Well, let's do one together.
We can do one together on the board.
Yeah.
After we do one together.
On paper.
Yes.
So mean.
I know, I'm the worst.
To make it
Oh my God.
Oh my god.
Okay, so if you take a look at this sheet here, I'm asking you to find a whole bunch of information without graphing it. So we're not going to, but think about how much, once I have the vertex, don't I also have the axis of symmetry? And isn't C super easy? I might actually do that first. D is super easy. And then domain and range we just talked about. Y-intercept is easy. X-intercept might be the only one that takes a little bit of work. So how about we do number 1 together?
Yeah.
Okay. So let's do the easy things first. Get those out of the way. So parabola. Is this one going to open up or down? Down, right? Because A is negative. So for C, I'm going to put down. So does that mean I have a max or a min? Min. Oh, sorry. Just kidding. Just kidding. Just kidding. Just kidding. Just kidding. Max. I don't know what I mean for the value. because you're going to have the vertex in A. So just cross out value on D. I don't even know what I'm asking for there. Let's see. You could find the Y-intercept really quickly. How do you find the Y-intercept? Yes, plug in 0 for x. So it's going to be 0 comma something. It's always 0 comma something. In this case, it's what? -5, right? If you plug in 0 for x, -5 comes out. So those are the ones that were super easy. You don't even really have to do any math. You just have to look and figure out what's going on. Okay, the vertex. Let's all take a minute, find the vertex, and we'll see if we all match. Oh, man. Yeah. Oh, well. Not every number is going to be perfect.
How'd you get 6? Yeah,
2 times A?
-4.
Right, so, oh, just kidding. So positive 3/4, everybody got it as their x value? Just kidding around. Okay, 3/4. Okay, now we gotta plug that back in and see what we get out. Luckily I have a calculator, make my life easy. Yeah, -3.875. Did everybody get the same thing I got? Don't just trust me, because obviously I'm making mistakes left, right, and center. So did someone else do it and get that same thing? -3.875. Anybody? Okay, now that I have the vertex, I have B. How did you find the axis of symmetry again? Do you remember from yesterday? It's just x equals, you have to write x equals, and x equals what?
3, 4.
Yes, it's just the x coordinate of the vertex, 3/4. The other thing that you get from the vertex is the range. We just talked about that. So if I jump down to letter F, now I'm dealing with the y value. And is y going to be greater than or less than -3.875? So remember how we do it. We look if we have a max or a min. If it's a max, right? Sometimes it's helpful to kind of draw it. A max means I have it down like a frown. So the range is going to be, that's the highest I'll ever get, and I'll get everything below it. So I want y is going to be less than or equal to whatever the y coordinate of my vertex is, -3.875. Awesome, so that one's done. Oh, the domain. Oh, we should have done that in the beginning, because domain's super easy. Its domain is just all reals, always. So that should be a freebie. And then the only thing we have left to do is letter H. How do you find the X-intercepts? X-intercepts. We just went over this.
Oh, you put on the Y.
You put in 0 for x.
For y. Right, you do the opposite. So if I'm trying to find the y-intercept, I put in 0 for x. If I'm trying to find the x-intercept, I plug in 0 for y. So that is the one that's going to require a little bit of work. So I go back to my equation, I replace y with a 0. negative 2x squared plus 3x minus 5. Now, this is a problem like you did in the last chapter. Solve this quadratic. I would try, I can't solve this one by square rooting. I'd try and factor it. So let's see. 10. Positive 10 that add up to be 3. I don't think we can do it, right? Yeah, so I can't do that. I'm certainly not going to complete the square. I would do quadratic formula here. So let's start off with the discriminant, because maybe if the discriminant comes out to be negative, what are my x-intercepts? There aren't any, right? So let's start with the discriminant, b squared minus 4ac, and see what comes out. So it's 9 minus 4 times negative 2 times negative 5. 9. Well, what do you know? This one does not ever cross the x-axis. So I'm going to write none.
We could have figured that out earlier because it's a negative
You're right. So
y and then it goes down.
you're right. So look at where your vertex is, right? 3/4 comma negative blah 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 blah. So think of where it is. 3/4 and then negative something. Do you guys get what she's saying? Because that's very useful. Here's your vertex, and then your parabola is going down. So it's never going to cross the x-axis. Very good. Okay, so that's how you do all of these pieces. All right, so let's stop this.